we continue our discussion on concepts in representation of data and information. We have already discussed about data types and binary representation of data. We discussed at length the number system, conversion and representation. Now we will move on to representation part. Conversion we have already covered, and we'll discuss the related concepts in the next few minutes. Let us start with the discussion of text representation scheme. In computers or any digital system, text representation schemes refer to the methods which are used to encode, to store and to process textual data. There are various schemes which are used to ensure that the characters in text and different types of symbols, they are represented well using binary digits, right? We know that digital systems only understand the language of zeros and ones, binary language. So, in order to encode these characters, textual characters and symbols into binary format so that system or digital system can easily understand, various encoding schemes have been devised. One of them is ASCII. ASCII stands for American Standard Code for Information Interchange. It is basically a 7-bit encoding scheme for representing characters, and using 7 bits, 128 characters can be represented. This scheme, ASCII, it mostly covers the characters of English language. But what about other languages? Because different languages use different character sets, different symbols to represent various sounds, right? And various other symbols are there. And across the globe, there are thousands of languages are spoken. So, how to represent the characters in those languages? Say, for example, in Hindi, we make use of Devanagari script. In Urdu, we make use of Nastalikh and Nas scripts. Like we use a Roman script in English. So, in order to handle or tackle the issue of representation of characters of different types of languages which are spoken all over the world, and in order to overcome the limitation of ASCII, Unicode consortium has come up with a solution, and that solution supports encoding schemes for multilingual computing. So, this Unicode is a universal character set especially designed to cover all the writing systems across globe, and it supports over 143,000 characters across multiple languages and scripts. There are various encoding schemes under Unicode. One is UTF-8, another one is UTF-16, one is UTF-32. UTF stands for Unicode Transformation Format, and these various variants of Unicode are popular these days. Let us see them one by one. UTF-8 uses variable length character encoding, and it varies from 1 to 2 bytes to represent each character. So, for representing English language characters, ASCII was being used. So it has backward compatibility with ASCII. But for other languages, it provides various coding schemes. UTF-16 utilizes 2 to 4 bytes for representing various characters. Apart from these, there are other encoding schemes as well. ASCII we discussed, which is 7-bit. A variation of ASCII is known as extended ASCII, which uses 8 bits per character, means to represent one character, 8 bits are used. Unicode, as we discussed, uses variable length bits or bytes. For UTF-8, it uses 1 to 4 bytes. One more encoding scheme, EBCDIC, Extended Binary Coded Decimal Interchange Code. It is an 8-bit encoding scheme. ISO IEC 8859 is another such scheme. UTF-8, UTF-16 and UTF-32 we have already discussed. Next is audio data representation. Since textual data has many different encoding schemes, likewise audio data also needs digital representation. Why? Because normally audio signals are analog signals and computer understands only the language of zeros and ones. So it must be converted in a form that can be understood by the computer system, and that is zeros and ones, the language of zeros and ones. So it must be converted into digital formats. Why? Because we need to store this data, we need to transmit this data, we need to process this data, and all this is possible within the computer system only when we have its digital representation. So various schemes are there to represent audio data. Some of the key elements in data representation I would like to discuss. One is sampling. What is sampling? Important concept. Sampling, as we discussed, that the audio signals must be converted. These audio signals are analog signals. So sampling converts audio signals into digital formats by measuring the amplitude at regular intervals. Another important concept in this is sample rate. Sample rate is number of times per second audio is sampled. The common rates include 44.1 kilohertz and 48 kilohertz. There are other sampling rates as well. Bit depth is another important concept. It represents number of bits used to represent each audio sample. It may be 16-bit, it may be 24-bit. What is important to understand that higher the bit depth, more precise representation of the sound would be. Now, another important concept is file format. You must have come across, because these days we use digital systems. One of the file format which is very popular is WAV. Another one is MP3, which is MPEG-1 audio layer 3. Another very popular file format is AAC, Advanced Audio Coding. So let us have a quick look of some audio data representation schemes. PCM is one such schemes, which is uncompressed. Differential PCM is another such scheme. Adaptive DPCM, differential pulse code modulation scheme. WAV we have just discussed, which is uncompressed. MPEG 3, very popular. MPEG 1 audio layer 3, it is a compressed scheme. AAC we have just discussed. OGG-Warpis, it is another very popular scheme. WMA, Windows Media Audio, is another scheme which is a compressed scheme. I'll discuss about compression later on. Next is image data representation. Image is another way of representing data. We have pictures, photographs, all represented in digital systems, whether computer or mobile phone or tab or laptop, whatever it is. There are broadly two types of image files or image graphics. One is known as raster image or raster graphics. Another one is vector graphics. This raster graphic is constructed through a grid of square pixels or rectangular matrix, and each of these pixels, it has a specific color value, right? Raster images are not scalable. I'll explain this term, scalability. We can use rasters in application like GIMP, Photoshop, Paint Shop, all these applications we make use of it. In the same way, we have another type of graphics called vector graphics or vector images, which are constructed through geometric shapes like lines, like curves, like fills, right? As compared to raster graphics, vector graphics are scalable to any size without any loss to the quality of picture or image or graphics. And we use vector graphics in application like CorelDRAW, you must have heard this name, Illustrator, Inkscape, very popular file formats that most of us know. SVG, EPS, WMF, PICT, these are the popular file formats for vector graphics, and the likewise GIF, JPEG, PNG, BMP, PCX, these are the file formats for raster images. Now, we were discussing about scalability. What happens when we increase the scale of raster image? Means when we enlarge it without changing its resolution, what happens? You must have find that it loses its quality and it becomes pixelated or it becomes blurry. Why it happens? It happens because each pixel represents a fixed amount of data or colored information, and enlarging this image file without changing this number of pixels, it spreads the same amount of information over a large area, and thereby it makes it lose its sharpness and it looks blurry. As you can see, when this image is enlarged, it looks like this, or when this emoji is enlarged, it looks like this if it is a raster image. As opposed to this, when vector images are enlarged, as we discussed, it can be scaled up to any size without any loss of quality. So, it will not have the problem of distortion or pixelation, because vector graphics are based on mathematical formulas which allow them to be scaled to any size. Look at this image, this part, right one. If it is a raster image, when it is enlarged, it becomes blurry. And on the left hand side is showing, for understanding purpose, if it is a vector image or vector graphic or vector art, when it is enlarged, it does not lose its quality. It does not become blurry. So, these are important aspects. We all handle images, so we need to have this kind of knowledge. Next is image data representation and colors. What is the relationship? See, colors are very important aspect, and we know the different color names: red, green, blue, black, yellow, and many such colors, and different shades of red, yellow, blue, green, black. But it is difficult to give it a name, right? How can computer understand these different colors by their name? For computers to understand this, a color model comes into picture. It is a system that helps to define and describe colors through numerical values. And there are many types of color models that use different mathematical systems to represent colors. Two most common color models which are in use are, as you can see, RGB and CMYK. RGB stands for red, green and blue, which describes what? Colors based on intensity of red, green and blue light. RGB, as you can see, is additive color model, which means what? The colors get lighter when mixed, and it is used in digital displays. Another color model is CMYK. C stands for cyan, magenta, yellow and black. And it describes color based on their percentage of cyan, magenta, yellow and black. And CMYK is subtractive color model, which means what? The color gets darker when mixed. It is used in printers. So, it is used for printing. Next is video data representation. To understand video data representation, we will discuss the important concepts. One is frame, compression, color depth, resolution. We will discuss them one by one. What is a video? A number of still images, when they are played at a quick succession, it gives the impression of a movie, right? So, it is a sequence of still images which are displayed rapidly. How many frames? Each still image represents a frame. It's called a frame. How many frames played in a second gives the frame rate, right? The common frame rates are 20, 30, 60. It is FPS representing frame rates per second. So, if certain system has 24 frame rates, it means it is displaying 24 still images in 1 second. In the same way, for 30 FPS, for 60 FPS, what is important to understand that more the frames which are displayed in 1 second, more smoother will be the motion. The video will be more smoother, right? And more pleasing to the eyes. Next important aspect is compression, which is important to understand video data representation. What is compression? It is the process of pressing something to make it small, like you press a sponge to make it small. So, in the same way, the more detailed a picture is, the more detailed a frame is, the more the number of frames per second, the more bulkier will be the data in the form of zeros and ones, because all it is represented in digital format using zeros and ones. So, if we want to have a smoother video, top quality video, it will be at the cost of storage. It will be storage hungry. It will require more space, right, to store. In the same way, more processing power to process it, more bandwidth to transmit it from one place to another place. So, to minimize this bulky data, to make it easier to transmit, to store, right, compression techniques are used. So, two types of compression techniques are used. One is lossy compression, another one is lossless. The name itself is self-explanatory. Lossy means when the data is compressed, it reduces the file, but while reducing it, it discards what? Less noticeable data. So, once something is compressed using lossy compression, when it will be decompressed, there will be a loss of data, but it will not be very noticeable. For lossless compression, when the data is compressed, X is compressed, and when it is decompressed, X will be obtained. In case of lossy, X is compressed, decompression will give X dash. Color depth, it is very important to understand this concept. As we discussed that a picture is represented with pixels. Higher the density of pixels, better would be the color, right? Better will be the picture. If the color depth is high, means more data would be required to represent different colors and its shades. So, as we discussed that it will add up to more data, right? So, color depth represents the number of bits which are used to represent color per pixel in each frame. Another important aspect is resolution. Resolution represents the number of bits used to represent color per pixel in each frame. And the most common resolution are SD, which is standard definition, HD, high definition, full HD or FHD, ultra HD, which is 4K, either 4K ultra HD or 8K ultra HD. As you can see, standard definition 480 pixels. So, when you see the mobile specifications of your mobile phones and its screens, or you come across this kind of terminology. So, if it is SD, it is 480p or 640 into 480 pixels. If it is HD, it is 720p or it is 1280 into 620 pixels. Same for full HD, 1080p. For ultra HD 4K, it is 2160p. For ultra HD 8K, it is 4320p. Now, common color models, we discussed about color models in images. Now, color models in video. The two common color models are YUV and YIQ. YUV uses properties of human eyes to prioritize information. Y is the black and white image, U and V are the color differences image, and it is used in PAL analog color TV standard. In the same way, we have YIQ, it uses similar idea. Common video formats are MP4, which is most commonly used for online streaming and general video playback. Many of us handle this kind of video files. MOV, it is Apple's video format, often used in professional environment. AVI file, you might have come across. MKV, it is another very popular video format. Next, data compression, we have just discussed about it. It is nothing but a process of reducing the size of a file or a data set by encoding it in such a way that uses fewer bits of data than original. Right? What is the goal of compression? The purpose of it is to save the storage space or to save the bandwidth or to save the transmission time without losing essential information, right? Lossy and lossless compression we have already discussed. There are very well known techniques used for data compression. One of them is a run length encoding technique or scheme. Another one which is very popular, Huffman coding schemes. One is LZW schemes, and there are other schemes as well. Let us have a quick look, which is a comparison of lossy and lossless compression. This table contains the feature, and we'll discuss each features one by one, and we say how the lossless and lossy compressions in terms of these features. Data retention. In case of lossless compression, when it is decompressed, the entire original data is retained. But in case of lossy compression, some of the data is permanently lost. File size. When it is compressed, the compression ratio are lower in case of lossless compression, and it is 2:1 or 3:1. But in case of lossy compression, it is very, very high. As you can see, 10:1 up to 100:1 is possible. In terms of quality, in lossless compression, there is no loss of quality of data. But in case of lossy compression, there is some loss, of course, within the acceptable limit, but it is there. Most common, file formats in lossless compression: PNG, zip, FLAC, TIFF, GIF, and we discussed lossy compression: MP3, JPEG, WebP, MP4, H.264. These are some of the examples. You can further enrich your knowledge and understanding.